Welcome you all my lecture series of automata theory and compiler design. In the today's video we are going to see about what is a finite state automata and with an real-time example and what are all the types of finite state automata. Already we know that what is an automata. Automata is nothing but it is an abstract machine. So automata contains a set of state and transitions. In our daily life, every action in terms of the state and transition. For example, considered if you want open the word in our system in our system means what is the first step. In the first state, suppose the system is switch off mode means for the first state it is in the switch off mode. After the power on, it goes to the switch on. In the switch on mode, in the desktop is open. After we are pressing the Microsoft Word, the Microsoft Word is open. That is another state of that word opening. So once the Microsoft Word is open, we are going to do the operations, and finally we are going to close the button. And from the open state to word open to we want to close the word means either we have to press that we have two options. Either we have to press the symbol like multiplication symbol, cross symbol, or we are going to continue means again we are going to go to the same state running state of or typing state of Microsoft Word. So these are all the terms of process we are doing when you are opening the Microsoft Word and do the process and close the Microsoft Word. The same thing also we are came through the daily life like the vending machines and ATM machines, and also the traffic light signals. For the traffic light signals, we have three lights. One is the red and yellow and green. Suppose the state green, from the state green, when the action when the timer is expires, it goes to the state yellow. Once the yellow timer is expired, it go to the state red. So again from the red state again it goes to the green, yellow and red. These are all the process in the traffic light. So this is the some automata machine. In the regular life we have seen that. So another example is the soda vending machine. So the soda vending machine also we have a several state and transition. Start with the ideal state to finally we are dispose the soda to the customers. So every state to another, every state have the transition to go to the next state. So every action in our day-to-day life we are having a state and transition process. So what is the finite state automata means? The formal definition of the finite state automata is it contains the 5 tuples. The 5 tuples are the set contains the capital Q and sigma, small q, capital F and delta. That is the transitions. The capital Q represents the set of states, and sigma represents the set of input symbols, and Q represents the initial state, and F represents the set of final states. So transition means one state to the move from state 1 to state 2 through the some input symbols. So this is the formal definition of the finite automata. So the finite automata is used in the lexical analysis phase in the compiler. So in the finite automata with the graphical representation is we have an input string or input unit. From the input unit it go to the automata, and finally based upon the transition input symbols it go to the output unit. So this is the representation of the finite automata. For example, the regular expression to the finite automata means we are having a or B means if from the state A we have either a transition or B transition, it goes to the state Q2. Suppose A dot B, that is a dot B, that is a concatenation operation means after reading A we are going to read the B, and finally in the Q3 it accept AB. Suppose A closer means we have a self transition. The single state we have a multiple occurrences of an A. So this is the representation of finite automata for the given regular expression. So the types of finite automata, it is a two types. One is a deterministic finite automata, that is a DFA, Another one is a non-deterministic finite automata, that is an NFA. So in the DFA means the DFA and the NFA differs only in terms of the state transition and also that epsilon transition. In the DFA, state 1 to single next state for the symbol for each input symbol, the transition is done. But in the NFA, transition from one state to multiple next state for each input symbols. And also the DFA does not contain the epsilon transition, but the NFA contains the epsilon transition. This is the major differences between the DFA and NFA. Next term is the transition diagram. So every automata it represented, it's told that it is a state and transition. So the combination of state and transition is called it as a transition diagram. So the FA can be represented using the transition diagram. So the transition diagram means it contains the set of input symbols and transitions and also the start state and final state. So the example of the transition diagram for recognizing the A or B closer ABB means the basic, we start with the basic symbols of ABB. So what is the description of the above regular expression? The string end with ABB, but before that we have any combination of A or B closer. So the basic string is an ABB, that is a 3 symbols. 3 symbols means we record the 4 states. So Q0, Q1, Q2 and Q3, these are all the states for the ABB. Before that we have any combination of A or B, so it can be represented in terms of the self loop. So this is the representation of A or B closer ABB transition diagram. So in this video we are came to know that what is the real time examples of the finite state automata and what is the formal definition of the finite state automata and also the graphical representation or pictorial representation, and within some examples how we can represent the finite automata and how the transition diagram represents for the finite automata and what are the types of the finite automata. Thank you.